Day 11, Advent of Code. Let's get it. What are we working with today? Hold up. Let me just check my stream. Check my streams. Working good. Sorry for coming late. Let me just check. Sorry for coming late. Cool. Audio is working good. Let's get it. What are we working with today? Make sure my VS Code is working. Day 10, part 1. Day 10, part 2. Right? Kanye East in the building. What's up, man? I haven't. Sorry for coming on a little late, but we're gonna get it done. How you been? I haven't seen you in the stream for a little bit. How do you increase font size? Increase editor. Cool. I'm gonna run some code down here. We're gonna get it running. Okay, let's look at this challenge. Hopefully it's not too hard. Oh wow. How's that going for you? What classes are you taking? So the ancient civilization on Pluto was known for its ability to manipulate space-time. While the historians explored their infinite corridors, they noticed a strange set of physics-defying stones. At first glance, they seem like normal stones. They're arranged in a perfectly straight line, and each stone has a number engraved on it. The strange part is that every time you blink, the stones change. Sometimes the number engraved on a stone changes. Other times the stone might split into two. Okay, what's your programming class? Like what are you learning? And in computer networks like internet and stuff? Is that what you're learning? Sometimes the number engraved on a stone, other times the stone might split into two, causing all the other stones to shift over a bit to make room in their perfectly straight line. As you observe them for a while, you might find that the stones have a consistent behavior. Every time you blink, the stones each simultaneously change according to the first applicable rule in the list. If the stone is engraved with the number 0, it is replaced by a stone engraved with 1. If the stone is engraved with a number 1 that has an even number of digits. Oh wait. If the stone is engraved with a number 0, it is replaced by a stone engraved with the number 1. Hey, mods in the building. Let's get it. Dude, I hope this is not too hard. If the digit is engraved with a number that has an even number of digits, it is replaced by 2 stones. The left half of the digits are engraved on the new left stone, and the right half of the digits are engraved on the new right stone. Oh, nice. OP, object oriented. What have you been like? What are they teaching you in you? Java or Python or C++ or something? So let's see. The new numbers don't keep that, would become 10 0 and okay. If none of the other rules apply, the stone is replaced by a new stone. If none of the rules apply, the stone is replaced by a new stone. The old stone's number is multiplied by 24, is engraved on the new stone. Okay. Nice. That's good that they're just going straight into Python. Because I've worked in some, like if you get introduced to other programming languages, like Java or C++ right away, I feel like sometimes it could make you not like programming. What else do we have? So let's look how this works. So what do we have to do? So after blinking once, your 5 stones would become the arrangement of 7 stones engraved with the numbers. Okay. How much times do we blink? In this example, after blinking 6 times, how many? Oh, so okay. Now we just need to recreate this pattern and blink like 25 times. and then see what the pattern of the stones are after. Okay, interesting. So let me read through these rules again. Let me grab my water. So what do we have here? So at first glance, they seem like normal stones. They're arranged in a perfectly straight line. So the stones are arranged in a straight line. If the stone engraved with the number 0, it is replaced by a stone engraved with 1. So 0 becomes 1. If the stone is engraved with a number that is even number, it is replaced by 2 stones. The left half of the digits are engraved on the left stone. If it's engraved with a number that is even, okay, if it has an even number of digits. Otherwise, the stone is replaced by a new stone. So the second stone one is multiplied by 24. The old stone's number is engraved on new stone. No matter how the stone changes, their order is preserved and they stay on their perfectly straight line. How will the stones evolve if you keep blinking at them? You notice, okay, so I think we just need to follow some specific set of rules. So we pretty much need to encode this logic of where if we have a number 0, we want to replace that stone with 1. And if we have an even number of digits, we want to like split it off into 2 stones. So what I'm thinking, it's kind of like a breadth first search, honestly. Let's see. I just recently paid for Excalidraw. So we kind of want to do a breadth first search. Patty Pads in the building. Random. What are we at? So we have these specific rules. Why is this in dark mode? Hold up. Let me fix this. I don't like dark mode. Okay, cool. So we pretty much have this. If the stone is engraved with number 0, it is replaced by a stone engraved in 1. So these are the rules. All we just need to do is define some set of rules. So if the number is 0, it is replaced by stone engraved by number 1. Rule 1. If it has an even number, it is replaced by 2 stones. Yeah. The new numbers don't keep extra leading zeros. Okay. Interesting. This is rule 2. Rule 3. If none of the other rules apply, the stone is replaced by a new stone. The old stone's number multiplied by 2024 is engraved on a new stone. So if none of the other rules apply, the stone is replaced by a new stone. Okay. So we need to check these rules in this specific order. Let's see. So we need to check these rules in this specific order. Okay. Let's work. So I'm thinking we do some sort of breadth first search. Pretty much we start with like, this is the first level and we kind of do like a level order traversal. Or we do a queue where we capture the length of the queue. And then for each time we blink, we process this level. So on the first time that we blink, we process this level 0. And we say the number is 0, it was replaced by a stone engraved with 1. So this becomes 1. 1. The left half are engraved with a new stone. If the okay, this one becomes 2024. Wait, let me fix this. Make this a bit bigger. This turns into 1. This turns into 2024. 10 has an even number of digits. So what does this become? It should become two things, 1 and 0. And then pretty much 99 should become, what is 99? It has an even number of digits, so this should be 9. It should also split off into 2. Something like that. And then this one should be 999 times 2024. Wow, that's a big number. So pretty much we get that. And then that's one level. So this is level 0, this is level 1, and we need to do that like 25 times. So let's see if this is right. This was the expected result. And yeah, we get that. That's a good expected result. And now for level 2, we just apply these same rules, but on this next level. So with 1, what are we going to do with 1? Times that by 224. What are we going to do with this? Split into 20 and 24. So it's like a breadth first search, but with a list of elements. Did I? Let's play around with this. 999. Oh, okay. I don't know. Did I get that wrong? Oh, 2024. It's all good. It's close enough. Let's see if I do this. 99 times. Did you say 2024? Yeah, you're right. Yeah, I should have got that. So we're gonna do like a breadth first search starting on. Let's start with this. If the original arrangement is 125 and 17, what we're gonna do is a breadth first search, and how to implement the breadth first search is using a queue. So let's start from collections, import default dict. We're gonna use a dequeue. And what we're gonna do is we're gonna start the queue equal to dequeue. We're gonna start the queue with these elements. And then we're gonna say, let's just run it on this like initial result, and let's see if we get the same answer if we blink 6 times exactly. So let's do for in range 6. What we're gonna do is we're gonna do like kind of a level order traversal. So we're gonna say for this in the range, the length of the queue, we're going to take the first element. So take the first element, and then we're gonna pop it from the queue. And then based on the element, we're going to apply specific rules. I think we should we work with strings for now? Let's see. Let me think about this for a second. Yeah. What are the rules that we need to apply? Let's see. Does that make sense? The current approach. We're gonna just do like kind of like a breadth first search, where at each level we kind of like apply the rules to that level to generate the next level, and then when we finally get to like level 25, we return level 25. Because essentially we just need to see what the stones would look like after 25 blinks. After, consider how. Okay, cool. Patrick, you're getting good, man. You're starting to learn breadth first search already. Rule number 1. Yeah, I'll iterate a total of 25 times. But honestly, right now, what I'm trying to do is just capture. I just want to make sure my thing works on the 6, like on this example case right here, blinking exactly 6 times. So these are the 3 rules, and we'll pretty much do that. If the element is equal to 0, then we'll take the queue, and then we'll append. That'll append to the left, or that'll append to the right. We'll append 1. elif the elem. Let's see. If we take the string of the element and the length of it, like if it has exactly 2 digits, or mod 2 equals 0, that means it's a multiple of 2. If the 0, 1, 2, yeah, if the length of the string mod 2 is equal to 0, that means that it has an even number. Then what we're going to do is we're going to find the middle point. So let me just figure out how to do this. Or yeah, we're going to find the middle point, and the middle point is going to be, let's see. We're going to find the left and right, and that it's going to be left, or we're going to get elem as string. We'll just do that here too, or do that right away right here. Equals string element. If the elem as string modulo 2 equals 0, then what we're going to do is we're going to get the left and the right. And the left of the right is going to be elem as string. And this is going to go from, so pretend the list is size 4. So what we're going to do is we want it to go from 0 to 2. We want the first, the left to be index 0 and 1. And then the rest to be 2 and 3. So what we can do is we can take, like, the middle will equal the length of LMS string divided by 2. So that will give us 4 divided by 2 is 2. And we'll say the left will be everything up to the mid, and the right will be LMS string everything from the mid onwards. So that gets us our left, right. And then we just append to the queue dot append left, queue dot append right. And we convert these into an integer again. And then last case, what we do, if none of the rules apply, the stone is replaced by a new stone. The old stone number is multiplied by 2024. So we do else q dot append the current element times 2024. So yeah, after that, if we print out the q for I in range, yeah, so if we print out the q, we should see like what happens if we process everything for one level exactly. And what? LMS string. Let's see. Line 25 is complaining. Oh, you're right. It's supposed to be mid. You're right. Okay. So after one go, yeah, we get 25317. So let's just do it like this. Blink equals 1. We start off at blink. After here, we print. We say f string blink at blink is equal to blink at blink is equal to list of q, and then we increase the blink. So if we blink 6 times, you can see this is our result. Let's just copy and paste that and just ensure that that's actually what we expect here. I don't know. Okay, blink 6 is that. After 6 blinks. This is expected down here. Yeah, it looks about right. 202, 4, 40, 48, 24, 4. Wait, what? Wait, it didn't look exactly correct. 02. Oh, yeah, I think it's good. I think it's good. How to make the visualizations? How to make the visualizations? Not sure what you mean by that. What do you mean by that, Dark Matter? let's just like, I think we got it running. So now I think all we need to do is blink 25 times. So after blinking 25, so all we need to do is after blinking 25 times, like return the length of how many stones we created. So let's just do this again. At the end, we're just gonna print the length of the queue, because that's what it would be like after blinking 25 times. And I'm not gonna do that, but I'm gonna do, let's say blink 25 times. 55312. That matches up. Now let's just use it on the big input. Let's use this on the big input. Folding laundry to the sound. Dude. This is a little bit easier without a couple Cedric tweaking on me. But that with Cedric was fun. Let's see. 220722. Alright, we got the next star. Let's get it. That was part 1. Hopefully everyone understood how exactly that worked. So the historians are sure are taking a long time. To be fair, the infinite corridors are very large. How many stones would you have after blinking 75 times? Really? They didn't even change the question. They just made me blink 75 times. Let's see. What if my computer just explodes from this? Uh-oh. Now I'm just blinking 75 times. And now it's taking forever to run. Interesting. Let's see. What did it say? The historians sure are taking a lot. To be fair, the infinite corridors are very large. How many stones would you have after blinking a total of 75 times? What does that even mean? I wonder if it's saying, like, how could I speed this up? So I wonder if there's a more optimal algorithm. Or I just literally let this run for a few minutes. Let's see. Let me think about it. How would I speed this up? Use a hash map? Use a hash map. Yeah, I'm trying to think. Dude, yeah, maybe my... Okay, I just thought for a second my computer went down. I don't know. I could either just let this run or try an input larger than 25 and smaller than 75 and see if it runs. I don't know. I already let this thing run for like... I already been letting this thing run for like 2 minutes. How would I speed this up? Like, we're pretty much... This would definitely grow like exponentially, maybe, depending on the level. Try an input larger than 25. I mean, I don't know. There might be a use of a hash map here. That's crazy. I have no idea how to speed this up. Let's see. Let's see if people even solve this. Let's see. Personal times. Oh, people are already solving this. Okay, let's see. Leaderboard, stats. Bro, I want to use a hash map, but yeah. Kanye East, you might be right. Let me try running this again in like a different Python 3, day 10. Part 1. Let's run it with like 25 again and just make sure it runs. That ran pretty fast. We ran it with 50. How does that? Why is that not working? Okay, 50 is too large. Let me think. This is actually interesting. Yeah, I don't know like how to speed it up, bro. Awesome guys, crazy. What should we do? Maybe we can like. Oh, I see. It might be creating like massive digits. So what we can do is, yeah, maybe we can create a hash map. Let's see. We can create a hash map, which is a dictionary. Yeah. Yeah, I'm about to use a hash map. So what I'm going to do is I'm going to cache like whatever element as string. If I already calculated it, if I already calculated what that element is going to turn into, I'm going to just, can you put the question on the side of the screen? Okay. I'll do it. Let's see. So Liam, basically what we're doing is we're taking like basically we have like these stones in a specific order, right? And then after, we have to apply certain like conditions to each stone. So every time you blink, all of the stones change. Basically, they change based on these specific rules, which are basically, look at this first level. When you blink, all the zeros turn to ones. If a digit has even digits, we split in half. We put like left of it on one side and we put right of it on another branch. And then also, if none of the rules apply, we pretty much multiply it by 2024. So that's like what the question is asking for. But let me like also put it on the side. But I think I'm going to use a cache because that thing is still running. So let's just use a hash map like what Patty Patch says. So we're solving this part of the puzzle. We're going to use a hash map and we're going to say if elem is in hash map, we'll continue, but what we're going to do is like Q or what are we going to do? Q. Because when we cache it, it could either turn into a new left or right digit, or we times it by 2024. So what we're gonna do is we're gonna have two elements. So lm2, pretty much the hash map is gonna contain values of like the initial thing, like pretend it's this one. The hash map is going to be pretty much like contains a tuple, something like this. So we don't have to calculate that because pretend the number is really big. If the number is really big, we don't have to like find a way to split it. So I think we save a lot of time there. So element 2 or element 1 and element 2 of the tuple equals hash map. And let me just stop these. I don't want these to finish running. Let's using up a ton of my RAM. But if the element is in hash map, what we do is we grab lm1 and lm2, and if lm1 exists, then we do q dot append lm1. If lm2 exists, then we do the q dot append lm2. And then we continue. We don't want to run this part. Otherwise, what we're going to do is if lm equals 0, we just kind of append it. But what we want to do is we're going to add to the cache. So we're going to say cache or hash map. We'll say hash map of the element equals the tuple, and we'll say 1 and none. Here we'll do the same thing, but we'll do int left and int right. And then here what we're going to do is we're going to say hash map of element equals pretty much this. So we'll put this, and then we'll put none, right? Now let's run this for like 50. See if this let's see if this runs any faster. Dude, is that Rohit? Is that how you use your hash map? If lm pop left, if lm is in hash map, we just take the tuple. So this might be kind of slow when we take element as string. So we just need to start optimizing a bunch of stuff. Damn, this is crazy. So we take the hash map lm, int left, int right. Maybe I shouldn't do that. Maybe I shouldn't turn it into an int twice. Let's do left, right. Or I should just like run this on a really fast computer. Left and right. Do left here, then do right here. Do left here, and do right here. Q dot append, we'll say result, just so we don't have to calculate this twice. We'll do result, then one is simple enough. Here, capturing the length of the string, you can do continue. We do if. Here, we can capture the length of the string once. And then length of the string. Length of the string here, length, or here. Let's see. Nah, that's a bad optimization. Okay, let me see. Let me run it for 25 again, and see if I get this same input. Just so I know my algorithm didn't get messed up. Where am I? Oh shoot, I messed something up. Wait. So what's the input? 28591. 22. Wait, what did I do wrong? If the element is in hash map, then if lm1 Okay, there. Just a small bug. So I'm pretty much just running the code on 50 and it's still not running. 222. What the heck? How can I speed this up? Rohit, you said you used the cache? I just used the cache. Element left, right. Is there a faster way to divide this? Wow, okay. Let me think. Yeah. I had to handle something. Lucky number 13 people watching on the stream, yeah. Dude, basically I just everyone drop a yeah. Like help me figure out how to improve this algorithm. I ran it on 50 and it's still running. So I just need to see how to speed it up. Honestly. Let's see. What's happening? How is it getting so fat? Or do we have to do like a depth first search with like I don't know if we might have to do like a depth first search. Depth first search to see how basically you'll see how many stones one, like if you take a 1, okay, we might have to optimize this using a depth first search. So we'll take a 125, pretend our only number is 125. Then we'll keep breaking that down 25 different levels. And then we'll cache like how much like stones did we like split into? Because essentially that's what we're trying to do. We're trying to see how much stones we split into. Let's see. Yeah, will that be helpful if we do a depth first search? It might be because it will capture these numbers faster. Yeah, I'm thinking of doing a I thought I was doing a DP here, but with the cache, like I cached, but I'm doing a breadth first search. So maybe if we turn this into a breadth first search, but like if we turn this into a depth first search, how do I know that I went enough levels? That's the thing. The reason I use like a breadth first search is so that I know when to stop like 25 levels in. Dude, this is crazy. I thought, yeah, I tried to optimize it, honestly. Let's see if it runs with 30. Like 30 runs pretty fast. Put it at 35. Okay, 35 might be the magic number when it's, 35 ran after a bit. 40. How does 40 run? Should we like multi-thread it or something? Or write this code in Java? Dude. Wait, let me think. Dude, this is crazy. Because maybe we can split it. Dude, 2 blinks, 3 blinks. Okay, 40, it's already crashing. I'm using a hash map. Oh, it finished with 40. So it's finishing faster. Dude, we might just have to let this run for hours. I might just have to let this run and just wake up in the morning and put in the result. But let me think. Because 40 just ran after like a few minutes. Let me run. I'm going to make a terminal called 75. And worst case scenario, I'm going to wake up and run that in the morning. Right. Or let's not try to do any weird variables here. Any extra work. We have to reduce the amount of work possible. Maybe if we know the length is 2. Is this a slow operation? I mean, we like slice it. And then we slice the other half. And we convert this into left into the right. Is that slow? James, have you heard of it? What does that even mean? That just sounds funny. Let me look it up. Iterative deepening search. BFS, considering a tree or graph a huge height and width, both are not efficient. Okay, combines. Wait. I don't know. This might actually work. Let's see. That sounds so complicated, bro. So there are 2 common ways to traverse a graph, BFS and DFS. Considering a tree or graph of huge height and width, both BFS and DFS are not very efficient due to following reasons. DFS first traverses nodes going through one adjacent of root, next adjacent. The problem with this approach is if there is a node close to a root but not in the first few subtrees. Okay. BFS goes level by level but requires more space. The space required for DFS is O of D, where D is a depth, but space required on BFS is O of N. Okay. This one combines depth first search space efficiency and breadth first search. They're teaching you this in school? That's crazy. Hold up. Did this finish running? Dude, that is not finishing running. Okay, wait. I'm just going to start it. So worst case scenario, I plug that in the morning. Yeah, that's crazy. What even is this? So like it does like a depth first search for a specific limit, then it stops. So it calls DFS for different depths starting from the initial value. In every call, DFS is restricted from going beyond. Okay. So it's like DFS and BFS combined, but it only goes like a certain level. Let's see what it looks like. I'm not sure if that's gonna help, honestly. But let's see. Let's see. I don't know. I think maybe if we do explore a breadth first search. Wait, if we explore a depth first search, we'll be able to uncover like more nodes. Because if we explore depth first search first, we were able to explore like larger numbers, and we might fill up the cache faster, and then we'll be able to like have more collisions. Because right now what I'm worried about is there's not as much collisions in the cache, so the cache is pretty much useless. So maybe doing a depth first search will like let us find like a more vast like range of values that we can later cache, like we can later use from that cache. Because maybe in breadth first search, yeah, I don't know if that even does anything. Dude, we might have to run this thing in like Java. Who actually solved this question? Let me see. Where are we? Let me see what this guy's saying. Let me call LeetCode Hard. He didn't join in, so. Well, I'm not gonna call him, but let me just see if he solved the question. Then reply to someone quick. One second. Use the lifeline? Is he? He's probably out and about. Man's probably out and about. And this thing is still running on me. Dude, is there anyone know of any ways to optimize this thing? Let's see. Anyone knows of any ways to optimize this thing? If element equals 0, we do that. Otherwise, wait. Length. Check length of digit Python. How to find the... I want to do this in a good way without turning it into a string. Yeah, I feel like we memoized it though, didn't we, Caesar? We might have to... Hey, this is slow. I did a fact... Okay. Doing mat 10... This is actually faster. Importing mat, they say it takes like... You guys look at this. If we do the mat.10 log, we could do it way faster. And then maybe to build the left and right, all we need to do... Yeah. Maybe taking the int left... All we'll need to do is like to actually split into left and right, we can do like what's it called? Like a right shifting of the integer in order to build like the left and right. So let's see, let's count like number digits, because people are... Wait, did that finally run? Okay, that finally ran, but that was only 50. Okay, I think we could actually speed this up a lot if all we do is we do import math. Then we do digits. And we're not working with negative integers. Run the code and go to sleep. Okay, let's do num digits. Num digits equals that. And then we'll say, so num digits equals that if the num digits mod 2 is equal to 0. Yeah. Okay. Now how do we get the... So num digits mod 2. And then we'll say, for the left and right, what we're going to do is like which DS topic? What do you mean? Like, what do you mean by DS? Data structure? So how do we do left and right? So let me look at shifting. Probably start with like, dude, follow my how to get good at LeetCode playlist. Like I start off with arrays and stuff. I think you should start off with arrays, then move on to like strings, then move on to linked list, then from linked list move on to like other things like graphs and stuff. Let's just use ChatGPT for this. How do I split integer in half using bitwise operator? Or I want to turn 2284 into 2284. Can you do that using bit operations? So integer division by 100 shifts the decimal digits down. Okay, first part. Damn, that's crazy. What if it was 222,844? I want a general algo. So this is a bit AI enhanced workflow. So let's see. Dude, that's what I was doing. But they're saying string turns it, like I don't want to turn into a string. Because we already know that that's not efficient. $75 still didn't run. Split number in half. What is this? So it takes the digit. Okay. Whatever. This looks legit. We'll take the digit count. We'll take the temp. While it's greater than 0, we pretty much divide it by 10 to grab the one digit. And we basically, how do we know we're at half? Assuming that the digit is even. Okay. This is probably a more efficient way to split the number in half. So what we're going to do is we're going to call this split number in half. And then we're going to do split number of half of the element. And then from there, we're going to store that in a hash map. Right? Let's see how fast that's going to run. Let's run that on my initial example and only run this 25 times just to see that it's actually working properly. Oh, y'all see how fast that went? That was crazy. Wait, go to day one. That literally finished in seconds. Cool. Let's run before it got stuck on 45. Let's run that. Should happen a lot faster. Hopefully. So now we're taking the num digits for element. If element equals 0. I don't know, 25 happened a lot faster. So let's see, num digits. We don't need to calculate this anymore. Left, right. LM times 2024. Awesome, guy. How much LeetCode questions have you done now? Let's see. Hash map. Dude, this is tough. I might just stop this 75 one. And just run it on 75. That, because you know that's not finishing. So I'm running that on 75. And then, I don't know. I think I optimized it as much as I can do. Well, I'll look at it one more time. If element hash map. Num digits. They apparently say that's way faster. And now we're splitting the number using like this. Let's ask ChatGPT 01 again. Switch it to 01. Can you split a digit faster than this? This is rough. What? Okay, you can split a digit even faster than that apparently. Let's see. So get the number of digits. Yeah, we assume that the number is even. Half that two. Okay, interesting. Okay. Because even before, the way you split it was like O of n time complexity. So let's split this. Let's try to split this even faster. So it kind of just computes it in one go. Let's say digit count. Because we already computed that. Nice. So we already have the digit count. Let's do split number half. We take the digit count of that element. Or num digits. Num digits. So now let's run this for like, now let's run that for 75. And then over here, let's run this for 25. Should happen like right away. Let's run it for 40. I don't know what's happening. That's like as fast as it can get. Compute the divisor. Let me try to look at my memory consumption. Give me a sec. Memory usage. Or activity monitor. Let's see how much. So Python 3 is using 1 gig of memory. Interesting. 99% of CPU. 100% of CPU. And I'm streaming. Dude. That is not a good combination. Oh, so it computed 40 pretty fast. Now it's just computing 75. I'm just gonna pass this whole thing to GPT. Let's just get it to speed it up. I don't know if I'm gonna get banned from Advent of Code for using AI, but they saw on live that I tried. Avoid math for digit counting. Use what? Computing the. Okay, so we're interesting. Use div mod for splitting. When splitting the number, you currently do that. You can replace with a single div mod. Cache powers of 10. Leverage hash map you already used to avoid. Just ensure that hash map is done before any computation. I don't know. They didn't really give me good optimizations. They just gave me some really weird ones. Get power of 10. Caching power of 10s. Like what? Okay, wait. Let's look at this bit length. Okay, so now they're getting us to use like C here. See digit count. So are these? So we'll do digit count and split number in half. So these are the new functions we're gonna implement. And let's see if that works. Dude, this is getting hard. Get power of 10. We have a cache the power of 10. So we'll get the digit count of the element. Once we get the digit of the element, we can split the numbers of half digit count. Or num digits. Yeah, we can do this. So now we're doing like some extra optimizations. Split numbers half, num digits. Okay, now that we have that, let's just do something. Let's try 25 again, just to make sure we actually get the right result. Damn, didn't even get the right result. It broke it already. So digit count, num digits, split number in half. Div mod, is that even a thing? I don't know. We might have to call it. Let's see. Like, if John Peralta CFA was here, I think I'd be able to solve this, but I need some help optimizing this. Decount. Tough. Let's see. Let me try this optimization here. Day 2, part 2. Let me try this code on theirs. I'll say Python day 2, part 2. Let's see. Or let's run it on, yeah, 40 is way faster. Dude, I don't know. GPT can't even give me a good result. Let's just feed GPT this whole question. Bruh, getting cooked. Okay. Can you solve? Oh wait, dude, it finished running, but it's not giving the right result. That's the annoying part. Like, if I only did 25. If I only did 25, my result should be that. But it's not. Like, you're giving the wrong result. Digit count. That. Then we split the number in half. Using the digit count again. Wait. Yeah. Like, okay, I'm feeding this into GPT, and then we'll call it a day. Let's see. Can you solve this? You've already. Okay. No, I mean, like, give the right code to solve that. Let's see how good this GPT-o1 model is. And if I need to upgrade to the ChatGPT Pro. Okay. No, this is like a unoptimal algorithm that we were doing before. I thought we were first off. Because just simulating. Can you make that faster? Dude. Yeah, I don't even know what this thing is doing. Okay, let's try this out. Is it memoizing? Are you memoizing? Damn. Currently, the approach only manages hard. Sure. Okay. Let's write this code. This is part 2. run it for 25 times. Not even giving the right result. So O1's giving buggy code. Shoot, we might, let's see. Damn. How did someone solve this? What are we at? Hour and 5 now? No, I'll see you guys on... I might have to see y'all on day... How did we place today? I'm gonna have to let this thing run overnight and I'll post an update. Let me see. So today we hit... Some people are starting to get this question, but maybe they just let it keep running. But I don't know. I'm gonna go watch a bunch of tutorials and figure out, because I seen some people solve it. So I'll see y'all in the morning. Thanks for watching the stream. Appreciate y'all. Peace.